Okay, so in this video, we're going to learn about what are called polynomials. And so that sounds like a crazy name, but I'm going to talk through what all those vocabulary words mean. And then at the end, we're going to add or subtract polynomials in function notation too. So first, let's talk about the vocabulary. A monomial is just meaning one term. Okay, a binomial means two terms. So that would be, so for example, one term would be like 5x squared. Two terms would be like 5x squared plus 3x. So there's two things added or subtracted together. A trinomial would be three terms. So that would be like 5x squared plus 3x plus 1. And then a polynomial is just any expression with more than one term. So a monomial is a polynomial, a binomial is a polynomial, a trinomial is a polynomial, or something with 4 or 5 terms is also a polynomial. So this is kind of like the general term. Okay, and so sometimes you'll also be asked to state the degree of the polynomial, and so that's easy. That's just the highest exponent. So if I'm looking at exponent, I can't spell. If I'm looking at this trinomial, because there are 3 terms, I'm looking for the highest exponent. So that's 4. So this polynomial has a degree of 4. This is a binomial, or we could call it a polynomial because there's 2 terms. And I'm looking for the highest, and that is 2. So this has a degree of 2. Okay, and then finally, I'm looking at this binomial, x plus 1. There's 2 terms. That's a binomial, or we could call it a polynomial. And this has just a degree of 1 because the exponent on x is technically 1, and the exponent on 1 is technically 1. So this has a degree of 1. Okay, and so in the last 2 examples, try to come up with pause the video and come up with a polynomial that has a degree of 2 and has a degree of 6. Okay, so if you wrote something like 2x plus 3 plus, 6x squared, that would have a degree of 2. A degree of 6 would be something like 6x to the 6 plus 5. It had the highest exponent of 6. So sometimes you'll be asked to write these polynomials in standard form. And what that means is this is usually how we write trinomials. So A, B, and C are coefficients. But to write them in standard form, you want degrees for exponents decreasing from left to right. So that would be like if I wanted to write this example of polynomial in standard form. The standard form would have the highest degree first, which would be the 6x squared. And then the 2x on that exponent would be 1. That has an exponent of 1, so that would come next. And then the 6 or the 3 doesn't have an x or an x at all, so that would be last. Okay, so that's kind of how I would write it in standard form. So some of the practice, the answers, you'll be asked to write your polynomials in standard form. If you flip it over, let's talk about like terms and non-like terms. So like terms are anything with common exponents. So for example, 5x plus 3x are like terms because you get 8x. 2x squared plus x squared are like terms. They have the same exponent. So we can write them. I have 2x squareds here plus 1x squared here. That would give me 3x squareds. We're not multiplying these exponents. If we were multiplying these exponents, then it would be 2x to the fourth, but we're adding them. So this, you have to be careful of that because we just came from a unit or the part of the unit where we were multiplying a bunch of exponential expressions, but when you add, they're different. You're adding the coefficients, just like you would do with that type of expression. Non-like terms are something like 5x and 3x squared. You cannot add those. And 3 plus 2x, right? You can't add those. We know that from the beginning of the year. You can't add 5x to the fourth plus 3x squared. Those are unlike terms, okay? So like terms is different than multiplying exponential expressions. Okay, so let's look at some examples here. I'm just going to kind of talk through two or three of them. So to simplify something like this, you can just distribute. Actually, I'm going to leave the 1 through 4. So all it is just distributing and combining things that are like, if there are things, there might not be. I'm really more concerned about example number 1. So I want to write all my answers in standard form. So that means I have to have my exponents in decreasing order from largest to smallest. So if I want to subtract 3x squared plus 4x plus 2 from 5x squared plus 10, I'm going to actually write this first. So think about, for these, I always think about a simpler example. If I say subtract 2 from 10, I'm really doing 10 minus 2. So same thing with these. If I want to subtract this from this, I'm really writing this first. And then I want to subtract this whole thing, which means I have to write that in parentheses to subtract each term. So the thing I always do first is I distribute that negative. I do that. So that way, and then I just write it out like this. So negative 1 times 3 is negative 3x squared. Negative 1 times 4x is negative 4x. And negative 1 times 2 is just negative 2. And then I go through and I think to myself, what are like terms? Well, these both have x squared, so I can add those together. 4x doesn't have a like term, but negative 2 and 10 are like terms. So this is actually equal to 5 minus 3 is 2x squared. I can't do anything with 4x, and 10 minus 2 is 8. And this is in standard form because my x is decreasing with the exponents. My highest exponent is in front, the next is there, and then my number without an exponent is at the end. So this is in standard form. So when it says standard form, that just means decreasing exponents. The rest of these examples are really just simple. You're going to do the operation indicated, and you can only combine your like terms.